Here's our network. We have PC0 and PC1 over here off of router R0. And we have PC2 and PC3 here connected to Edge. These are in their own local area network. These are different local area networks over here off of router 0. We have 4 servers that we want to access: FTP server, the employee records server, the Fastnet server on the outside, and a malware server on the outside. We also have an internal local DNS server, and that'll be used to access each of these 3 servers using the URL. The employee records server will be accessed using employee records. Fastnet will be accessed using www.fastnet.com. And malware, the malware server will be accessed using www.malware.com. Right now, we're going to demonstrate the connectivity throughout the entire network. There are no access lists in place that restrict network traffic. We're just going to use some examples with these end devices. We're not going to do all end devices to all servers. PC0, employee records. PC0 to the FTP site. Username is Cisco, password is Cisco, and we're in. Let's try down here in this network segment. Employee records. FTP site. Cisco, we're in. If we were blocked, we would not even get here. Connection refused. Okay, now let's look to get to the outside sites. PC3, Fastnet. And now let's go to malware. Okay, so that's from this network segment. Now let's go over to here, PC1, Fastnet. Malware. We can see that we have open access throughout the network. As our example for using an access control list to deny certain traffic within the network, we're going to deny host 10.1.1.134 and 10.1.1.200, that's PC1 and PC2. We're going to deny them access to the employee records server. So here we have our access list list 5, deny host 10.1.1.134, deny host 10.1.1.200. Now notice we use the word host here. There is no subnet mask or inverted subnet mask here because we're specifying a particular host. Now these access lists have to be applied to a router interface in order for them to take effect. The server to which we're restricting access is on the G02 connection for router 2. So we're going to apply this access list to the outbound of G02. We're not going to apply it to the inbound because that would slow down traffic traveling through router 2. In general, with standard access lists, you place the access list as close to the destination as possible to minimize the effect on network traffic that is not affected by the access list. Let's go ahead and apply these. Okay, so there's our access lists. And now we're going to apply them to interface G02. Now if we're going to use the show IP access list command, So access list 5 is in place. If we do a show IP interface, G02, we can see that access list 5 is applied to all outgoing traffic on that interface. PC2 is supposed to be blocked. Let's try it. Okay, now number one, we see the request timed out. If we go in the router R2, we do a show IP access list, and we have 12 matches, and that's from the one try. We'll go to PC3 and access the same website. That's blocked also. Now there's a reason that that is blocked. If we go and look at the access list, match count did not change. What's missing is a very important statement. At the end of this access list, we need permit any. Without that permit any statement, everything will be denied. So now we're going to go back into R2. Access list 5, permit any. Go back to PC3. And now we can get in. Let's verify that we still can't get in from PC2. Still can't get in. Now let's try the other two PCs. 134 should be blocked. .134. And we should get an additional 12 instances or matches to that record. Here we see we've got 12 matches from the 134 and an additional 12 matches from the .200. Now let's make sure we can get to the employee records from PC0. And we're in. So this demonstrates the use of a standard access list. It also demonstrates the importance of the permit any at the end of this access list. And it also demonstrates how we applied it to the interface. That's the end of this video.